229 points to pass the complete segment. So, for example, uh, you got like maximum marks in segment 1 and 2, but you did were not able to get the full marks in segment 3. So but your total of all the segments is going above 229, or at 229, so you will pass the CSWP exam. Now, depending on the exam codes you get, uh, either you have purchased them, or you got get those as a part of subscription, or got as a part of giveaway during a lot of SolidWorks events. You will be able to do one segment at a time, or you can give all the segment in one go. So make sure to check your vouchers, how they have been listed, like whether they are a complete exam code, or whether they are given as like segment 1, 2, and 3. So when you uh, log into your virtual tester account with the app virtual tester, so it will show you over there that if you have the full exam code, or if you have segment by segment. So let's talk about segment 1, 2, and 3. Like what are those segments and what exactly they contain? So segment 1, CSW1, it you are required to create a model based on the given information, and then on the subsequent questions you will be asked to change some of the features, some of the dimensions, or similar kind of things throughout the exam. So there will be mainly two type of questions. One could be the multiple choice, we call them MCQs, or there will be questions where you need to enter an answer into a text box. Then segment 2, for the segment 2, you will be given some set of models, which are mainly parts, and then you will be required to change some dimensions, features, create or modify some configurations. Segment 3 is completely dedicated to assemblies or sub assemblies. So you will be given some components to create sub assemblies and assemblies, and then you will be asked to do collision or interference detections. You will be asked to do create uh, coordinate system, verify center of mass with respect to that um, coordinate system, override the mass properties, or do some component replacement, and then again verify the center of mass. So before we actually go into the what are the topics or the tools required during the exam, I would like to touch base on one important thing, which is called design intent. So design intent is plays a very vital role when you are building your models. It's not specific to SolidWorks, but to any CAD system you are using. With the design intent, it defines how your model will behave when you make a change, or when you remove or add something. So how the overall model is going to behave, and the final shape of the model would be. Uh, as you can see in the picture, so we have one component in the magenta color, and two different people started doing the same part, right? One started it on the front plane, whereas the other guy started on the top plane, because that's how the orientation of part in the question is. So that is another thing, like how we want to orient our model, and with the right selections of the orientation, like on which plane we want to start our model, or how we want to order our features, it will not only it will save a lot of time, but it will also save a lot of frustration, because when you are going to create the models, and you are going to compare with them with what with the questions given in the exam, if you are not following the best design intent, there is a good chance that you are going to make a mistake. So make sure that you choose the right design intent. And the most important part is that design intent cannot be automated, and a user needs to capture the best design intent based on what he or she is going to model, or what the question is asking them to. Now, Now we are going into the exam topics. The first topic is global variables and equations. So global variables or equations, so they will be the main ingredient when you want to do the segment one. The best part about global variables or equation is that you can create the global variables on the fly or using the equation editor. So let's look at like how we can create the global variables on the fly, or how we can use the equation editor. So we'll look at one example of each. Oh, sorry. Okay. Is the SolidWorks screen visible?
Yes, sir.
Yes, sir, visible.
Okay, great. So in the exam, you will be asked to create certain global variables and link your dimensions to those global variables, and then throughout that particular segment, you will be asked to change the values of those global variables so that your model is going to change, and then you will be asked to get the mass properties or pick one of the value from the mass property. So I have created this base plate, and I've double clicked on it so that I can see the dimensions. So right now you can see there is there is nothing assigned to these equations. So let's assign a global variable a to this dimension, which is 213, and then another uh, global variable b to this 200 dimensions. So you can just double click on it, press equal to, and then put your variable name, right? And you can also see it coming it in the drop down. So you can select from there as well. And the moment you click OK, you will be prompted with this message: create a new variable named a. You can say yes, and then we can go to this equation manager, right click on it, manage equations, and you can see a global variable is added over here with the value of 213. Now let's add another variable, which is b, and I'll say 200. So we have now two variables a and b. I'll click OK. Now I will double click again on the feature, or while you're in the sketch mode or in the feature edit mode, you can assign the global variable over there. And I'll click over 200, again press equal to. And because we have global variable defined, now you will see this list of global variable, and you can select the desired global variable from here and just click OK. Now, we used two different methods. One was we created the global variable on the fly, and second, we created the global variable from the equation manager. Uh, Otherwise, it will work in the same way. But there is one major difference over here. Like when we create global variable on the fly, we can change their dimension right away from the model graphics area without going into the equation editor. So if I want to make it 250 and click OK and rebuild it, the dimension will change. Not only it will change over here, you can see it has changed in the equation manager as well. But the global variables which are defined through equation manager, you cannot change. You can, oh, it's letting me change, but sometimes it won't let you change it. It's good to see that it is letting me change. Let's say, but usually it does not let you change from here. So for that, you have to always go into over here, and you have to change it from here. So it's good to see that it is letting me change. So I'll save and close this file. Uh, if you have any questions, I'll request you to capture them for the last of the session, and we'll have some time to discuss all the questions or any queries you have in the mind. Thank you. Now, we were talking about design intent. So feature order is one of the key factor in when we are talking about the design intent. So not only the model orientation, but choosing the right features order saves time. It also help to keep the desired intent, and then you also need to make sure that you are using the right feature for what you are creating. For example, if you are making a shaft, so shaft can be created in like minimum four different way. sorry, 4 or 5 different way. One is you can extrude the shaft, you can revolve it, then you can sweep it, and you can do a loft. Now, you also have to think like how you are going to manufacture a particular model, right? And that will also adds to your design intent. So usually a shaft is made by doing a turning, which is basically you have a workpiece rotating at its own axis on the lathe or turning machines, and then you use tools to do the required cutout to get the final shape. So effectively, you will use the revolve tool to create the shaft. So it's basically like a cake structure, like how your cake is made, right? So there is one big piece, and then on the top there is a small piece, and on the top there is another small piece. But when you are doing a turning, you can do all it in one single revolve instead of creating three different extrude or other features. So so we have two pictures on the screen. So there is one picture on the left where like the user did not care about choosing the right feature order or choosing where the user needs to put the features, whereas on the other side users has like thought of little advance, which not only saved the user some time but also helped him to keep the desired intent. So let's look at this file first. So what user did, he created a base file, then added some fillets on the end, and then did some extrude and a cut extrude, right? And then the user added the other fillets, which you can see over here. Now, what if this fillet changes? So let's look at how this cut extrude has been done. So it's basically an offset from this face, which means whatever fillet will be there, this fillet will be 10 plus or whatever is the offset value of that fillet. But instead of using that design intent, user created this fillet as a separate tool and as a separate feature, and this fillet as a separate feature. So in if let's change it to 12, but because the design intent was not used correctly, so this fillet instead of like 25, right, it should have been like whatever is the offset value. He created the same thing like this, and then he know because there is a cutout to be made, and that cutout is an offset from this these edge and this fillet feature as well. So he considered that into the design intent, and this offset was created using that feature in mind. And if I change this offset to say 15, this fillet will automatically update. And finally, he added the rest of the fillets. Now, I would like to show you a few uh, tips and tricks over here. So let me just roll it up. So we have seen that this there was an extrude feature created in this corner. So let's create one more. I'm using the shortcut L for the line key, right? So I'm doing an L, and then I will go to the extrude, and I will not. Oh, right. Hmm. No, SolidWorks is behaving like this. But what happens is when you create a sketch like this, or maybe I should be in the sketch mode. Yeah, sorry, I should be in the sketching mode. So I drawn this, and I went to the extrude command. And the moment you do this, I'm not sure like why it is not running. SolidWorks will prompt you that should it close the rest of the edges. And the moment you do that, SolidWorks will automatically create these two, or mm, these two edges on its own. So let's see why it is not doing it. Mm, or maybe we can try to give a dimension if that works. Let's try again. No, it's not helping. No, no. Sorry, for some reason it's not working. But uh, you can try it on your machine. That what SolidWorks will do is like when you have an open sketch, which is coincident with the edges, SolidWorks will prompt you that should I close the sketch or not? Or maybe let's me try one more time. No, it's not working. So okay, let's move on to this one then. The second tip, right? I will delete this. So one of the thing I have seen user doing it, like when they have to do an offset on a face, what they will do is like they will select all the edges individually. Instead of that, what you can do is you can simply click on the face. So SolidWorks will then automatically find all the required edges, and then either you can click inside to get it offset, or you can select the direction from here. So instead of like selecting all single edges individually, you can simply click on the face, and that will let SolidWorks find all the required edges on that face. And then if you have to do a fillet on so many, usually I don't recommend sketch fillets, but sometimes you have to use sketch fillets. So if you have like a lot of corners or a lot of vertices where you want to add fillet, so just go to the fillet command, enter your fillet. Let's say we'll do 5, and then cross window like this and enter. So instead of like individually picking up each corner, you can select all the vertices, or even if you do control A, it will automatically select all the vertices and it will add all the desired fillets to the end. So these were two or three of the tips. Like this also works. I'm not sure like why it is not working. So let me just try one more time by deleting all of it. So let me just delete all of these sketches. I'll try one more time. So align, and when I go to the extrude, for some reason it is not working. Ah, no, sorry, it's not working. So I would suggest you to please do try it out. So when you have a sketch like this, an open sketch, and when you try to extrude it, SolidWorks will prompt you if you want the sketch to be closed, or you want it to be converted into a what do you say, a thin feature. So okay, uh, another fun quiz. So anybody wants to answer, maybe in the chat or uh,
Cheeseburger.
oh yeah, yes, cheeseburger. That's correct. Prabhu, you have sent me a message. Can we flip the direction? Uh, yes, we do can flip the direction, but for some reason, I'm not sure like why the SolidWorks is not prompting to show the direction. But I'll try to find it out at the end of the session why it is not working, and then we'll definitely find it out why it was not working. Okay, offset from surface. Uh, Many people, when this is specifically regarding to one of the questions, it's in the sample exam, but I'm sure it will be there in your daily life as well, or in the actual exam as well. So in the sample exam, you are given a thickness which is of 5 millimeter of that cut extrude, which is from the bottom face. So now instead of using the offset from surface command, what user do is like they will calculate what is this thickness, right? And then they will calculate, okay, how much uh, depth I need to make to get this cut out and to get this dimension of 5 millimeter or 10 millimeter. So I will increase it to 15. And this is what they will do, that every time there is a change in height, so let's increase the height. So let's say I will make it 25. Now, once you do that, this will get changed and the user will forget that they have done the calculation in a different way, and now they need to increase or decrease the depth of this cut extrude to get the right answer. So instead of doing that, when you are doing the cut extrude or even boss extrude, right? So instead of using the blind, simply use offset from surface, define your offset phrase, and define the thickness you need. And then whatever thickness change you will make. So let's, this is now 5 mil, right? And now let's change it back to 20, and let's check this thickness again. So this is again 5 millimeter. So you have to make sure that you use the right tool to keep your design intent intact and capture it correctly. I have seen, like from last couple of years, I have seen that users have messed up some of their questions because they didn't use the right unit, decimal places, or even the material. So you need to make sure that you are reading the questions carefully, because in some of the questions they might change the units or the decimal places or even the material as well. Mohammed has sent yes, or maybe I might have this option closed. Yes, Mohammed. Yeah, that is, this is the right command, or this is the correct prompt. So so everyone, I would suggest you to look at what Mohammed had shared in the chat, where he is showing the option I was saying. So when you do a half sketch, which is coinciding with the edges, you will get a prompt. Maybe I have that prompt off due to some options. So yeah, so getting back onto the unit decimals and materials, so make sure that you read the questions carefully. What is the unit system being asked? What are the decimal places? What is the material? And you have to use them effectively to get the right answer. Otherwise, like, you will be juggling, like, why my answer is not matching with one of the options given, or why I'm not getting, or why my questions was wrong. And in the recent version of SolveWorks, like, they have provided a search option in the material uh, manager, so where you can simply search for the required material uh, very easily. And I would also just suggest you that when you are applying a material, do not 100% rely on the material name. Make sure to verify the other properties given in the exam, because there could be like two material, maybe they might be closer to each other, might have same name. So like the exam had alloy steel, right? So now we have, like, with the alloy steel name, we have three names. So we have to make sure that we are using the current density of the material which is given. Otherwise, your answer may not be correct. And once you have selected the material, you can simply click on apply, and the material will be applied, and you will get the right answer. So use the search for material, and then make sure you verify the density given in the exam. Mass properties. So during the segment one, and I think during the other segments also, you will be required to check the mass properties. In the mass properties, you might have to enter center of mass, or maybe the weight, mass of the model, right? So SolveWorks provides you a tool called mass properties itself, where you get all the information you need to answer those questions, or even these are helpful in your daily needs. And as a tip, I would suggest you to assign a keyboard shortcut to both Mayor and mass properties, so that it makes it easier for you during the exam and you are not spending time trying to find out, okay, where is the mass property tool. So for me, I have assigned M for the measure tool and W as a significance of weight to the mass properties. So if I press M on my keyboard, I will get the measure, and you are seeing this name as mass property because that is the model name, but and it will always show your model name over here. So that can help you if you want to check something during the exam to make sure that yes, your dimensions are matching. And now I'm pressing W on my keyboard, which gives me the mass property windows. So make sure to assign any keyboard shortcut which you feel would be better for you to assign. So there is no hard and fast rule that you should use MW. You can assign any keyboard shortcut to your needs, and then you will be required to answer the questions. And you can also copy paste. I'll be talking about this one again later, but what you can do is you can always uh, collect the required value if it is mass properties, or it is like yeah, if it is like mass of the component, you can always copy and paste into the exam. Make sure that when you are giving the answer, where you have to enter the answer, no units are entered into that text box or the answer box, otherwise that answer will get invalidate. So make sure you need to enter only the numericals and no other uh, annotation or no other alphabet should be entered into the exam answer box. Delete face. Well, I would not suggest you to use the this particular command every time you are in trouble, but this tool will be helpful when you are in ultra trouble, I would say. So, in one during one of the exam questions, you will be given a part, or you will be modeling a part where you will have to modify some of the things. So, for example, we have this part and it has this extrude boss, the extrude feature on both of the side, and exam may require you to remove it from just one side while keeping the design intent intact. Now, uh, the first thing user will do, like they will edit the feature, they will remove it from the other side and then uh, edit this cutout which you can see over there to get to the right answer. But it may not be possible if you are given a part which has imported body and no history. So this tool will be the delete phase will be helpful when you want to do it very quickly. So this is the original file, and you will be required to create like this and then either verify its mass property. So let's see how we can use the delete phase, right? So let's see. So you will find delete phase and insert phase, delete phase. You can select delete and patch, and not this one. So did we see the magic? So Solvex automatically computed rest of the thing. Now, if we have to do it other way, which means you will have to maybe cut extrude this, do again a boss revolve of this, sorry, a boss extrude for this, and then do a cut extrude for this, remove this all of it, and which could have taken a lot of time, and there is a good chance that our model may not be correct. So instead of doing that, try the delete phase first, and if that is not helping, then you can look out for different methods. And this is how you will get this easily. So it didn't take much of the time, and no additional computing was required, and we still kept our design intent because we did not change any values. We just remove the unwanted feature as per the questions. Okay. Similar to delete phase, we have another a friend. Similar to delete phase, I would say Move face is also a friend, which is a friend in need, right? So so whenever you are in trouble, go to the move face and request it to help you get out of the trouble. So uh, I in one of the questions you may be required to move a certain hole or certain face or certain features, right? So from this you may be required to do it this. Now there is a good chance that no feature history is given, right? You are not given any feature history, or even if feature history is given, there is some design intent that this hole or this particular feature is onto a center line, which means no dimensions are given, and yet they require you to move it by certain amount. So let's see. So this is the feature, and if I look at this particular hole, right? It is on the center line. So if I have to like work out, what I mean is like I'll have to edit this feature, then move it up and down as needed and add the required dimensions, and then again I'll have to work on the chamfer. So instead of this, what we can do is we can again go to insert face, move face, right, and select these three faces, right. We'll say translate, and let's say we want to move it upwards in the y direction by 10 mil. So we did not change anything. We did not went into the feature editing mode. Uh, can everyone please mute your mouse? Oh, sorry, mic. Thank you. So just with the help of one command, right, we just moved our feature 10 millimeter up, and we still kept all the design intent. So you have to make sure that you know the right tool when you are giving the exam. Advanced shell, like how many of you have used the shell commands, or if you know like what is the shell command?
Yes, sir. I have used.
So in the solver shell command, what we can do with the shell is like we can hollow out a part, a model from the inside, and we can also remove any particular face we want. And what it does is like it will add the given thickness value to rest of the faces, right? But in one of the questions you will be asked to do a little advanced shell, which means doing a multiple thickness in the single feature. Okay, so let's look at the section view of this. So it's a multi-body. I have created it as a sorry, multi-body tool because I want the part symmetrical on the top plane. Now, you will be given a certain uh, model in the segment 2, and you will be required to change from a continuous thickness to a different thickness. Now, what you need to do is you need to simply edit the shell command, and on the upper side, whatever you have, like whatever face you will select will get this thickness. But on the lower side, you can define multiple thickness for different faces. For example, for this face, I want it to be 2 mm. For this face, I want it to be 3 mm. And for this face, I want it to be, say, 5 mm. So we have four different thicknesses in the same model using one feature. And the moment you click OK, so so this overall thickness is 1 mm, then this is a 2 mm thickness, this is 3 mm thickness, and this is a 10 mm thickness. So instead of like doing different workarounds, you can use the shell tool itself to create different multi thicknesses in the same feature and in the same part. And also, in one of the questions, you will be asked to create a part which is shelled on just one side, whereas on the other side, no shell is required. So, what you need to do in that particular one, you just need to simply reorder the shell and the mirror command, and and rest of the things will remain same, and you will get your required model and the required answer. So this will be similar to one of the exact question where you will need to be sorry, you need to shell on just on one of the sides. Uh, we got a rollback bar in the models. Unfortunately, it is not available in the assembly. It is only available for the part models. So by rolling back a part, it basically we temporarily suppress the features, and then we can review those features and investigate the model to find out uh, how the model has been made. First thing. Second, what are the different parent and child relations between those features and the features which are above them or which are below them. So for this one, let's look at this particular component where we want to modify this component to something like this. So let me just open up. Now in this one, I have a base extrude, so I'll just roll it back. I have a base extrude, then I'm given a fillet on the four corners, and then I have a fillet at the base, and then I'm doing a shell. Now, one thing what I have seen people is like they will sometimes they will do like this. So they will shell it out on the first, and then they'll start adding the fillets, which totally invalidates our design intent, because now you will have to calculate the fillets on the inner side as well, and that is going to take a lot of time. So make sure you are using the right design intent and right feature order. Now let's change this part. So one thing is like what we can do is we can just modify this sketch as well, adding the cutouts on the end and then adding another feature. But instead of that, let's make it a little easier. So I will add two sketches over here, maybe just random sketches. Though I am a fan of doing a fully defined sketch, but uh, I'm not, and just to save time, I'm not going to do it. Right. So let's now I'll simply oh, sorry, cut extrude, select this feature, right click, and through elbow direction and OK. So this is one of the change, and then let's make another change on the top. So we'll do it again like this. I'll do a center line.
ये वाला नहीं है इससे अच्छे होंगे
Can I
इसे
request everyone to please mute your mouse? Thank you.
इम्तियाज से लेके गए थे इम्तियाज वहां से लेके गए थे संवाद से
Sayed, can you please everyone to the
गुलबार
mute? Thank you.
नहीं कोटा में नहीं है
Okay, sir. Hamza or Rahman, please mute your mic. I'll see what I can do.
Thank you. So when you have a center line in place and you select the center line along with any of the solid uh, sketches and you click on the mirror command, SolidWorks will automatically mirror along that center line. Now there is one more trick over here. You go to the mirror command. If you are in mirror command, you select your entities, and the moment you select your entities and press right mouse button, SolidWorks will automatically jump on to the next option, which is asking like to select which entity or which line you want to mirror about it. So you can select over. So instead of like taking your mouse to this box In case you have not pre-selected a center line, you can just, the moment you select your entities, you can just simply right click and SolidWorks will jump onto the next window. This trick will be available for many features and you can explore them. Let me show it once more. Look at the cursor, it changes to an enter, right? So you can see the cursor right is acting as an enter button. So I'll click on it and then click OK. And then we can do the cut extrude
Amdad,
again through all and OK. So we have this feature ready. Now let's add the fillets. Fillets will be broken because we removed all the edges. So let's clear them all. Click on this. I have like selection toolbar set to off. So if you have it on, you can click on the edge and SolidWorks will help you or prompt you that whatever edges you want to select. So we'll select the desired edges, click OK. We'll do the same thing for the fillet too. So instead of like this edge, we can simply select these three faces. So we have the major design changes done. And now let's go to the, so instead of like doing a lot of complication in the base sketch itself, we added two more features to get to the desired result and to the desired model. Sorry, one thing I forgot to show you the dynamic references. So let me go back to the model, right? So if you have these two enable in your model, this is available for assembly as well as for models. So you can select them, both of them. And if you go to the any feature or any sketch or any feature, it will show you what are its parent features and what are its child feature. So we call it a parent child relationship. So using that, it can dynamically let you know that this particular feature is dependent on which features or which particular reference geometries. So you can easily find it out. Or other option is you can, in case you are using an older version where this option is not available, you can right click and go to parent child, and it will list all the parent child relationship in the prompt up window. So you can see that for the cut extrude, sketch 3 and boss extrude 1 is the parent, while the fillet 1 and fillet 2 are its children. Which means if I delete this feature, SolidWorks will ask me, should I delete the child as well? So during the exam, you can, if you are required to find the parent and child relation, you can use these tools. And even while you are working on your projects, you can use these tools if you have to frequently find out the parent-child relationships. Configuration. So, how many of you have used configuration?
Yes,
Yes,
sir.
yes, sir.
Okay, great. Okay, so in the segment two, you will be asked to, you will be given a model and you will be asked to create configuration from one of or two of the given configurations. And in that, certain features you will have to disable or you have to move them or add the feature. So if you look at the three configuration in the picture, so right on the right hand, left hand side, we have configuration A, and then we have configuration B, and then we have configuration C. So there are some features common in A and C, and there are some features common in B and C. And then we also see a feature which is in A, but in C that has been moved to a different location. So what we can do is we need to understand how the configuration work and uh, what are the main thing we need to look at when we creating a configuration. So I'm in configuration A, right? And I want to create a new configuration. So we create configuration in two way. One is a direct configuration, which we can call it as like a parent configuration. And then we also can create a derived configuration, which is which needs a parent configuration, and it will be linked to its parent configuration. So whatever changes you will make in the parent configuration, that will be derived, or your drive configuration will be driven by those changes. And second is whatever configuration you have active in the model, and if you add a new configuration, so SolidWorks will assign the same features to that new configuration. So let's add one more configuration. To do that, I just right click onto the configuration and say add configuration. Now, one thing you need to uh, look at when you are creating a configuration, that you need to make sure that you select this option, suppress features. Now, what this option does is, when you create a new feature in that this particular configuration, it will be suppressed for rest of the configuration, unless you tell SolidWorks that do not suppress this feature for this particular configuration. So I'll assign it a name D and click OK. Now let's create one quick feature over here, maybe just extrude tool and a slot, right? And I'll say through all and okay, right? So we have this feature enabled. Because we have selected that feature, suppress feature, this particular feature will not be available in any of the configuration. Now, how do we tell SolidWorks to have this feature enabled in any another configuration? The simple method is right click onto the feature and select configuration feature, and you will be given this table. And let's say we want to unsuppress it for config B. So I'll select it and say OK. And now if we go to the configuration B, let's suppress this. So this slot will be available. So this is something you will be required to do during the exam, and then find out what are the mass properties uh, by adding or removing certain feature of the part. So what are the changes in the mass property for that particular configuration? Or you may be required to ask, like, if you are given a certain model, how many configurations are there? Or you may be required to create an additional configuration with some features which are suppressed in particular configuration but are available for that configuration or its parent configuration. Coordinate system. So coordinate system define our x, y, and z directions of how our model is in the space. Oh, sorry. Okay, let me open up this one then. I'm not sure why. So I'll delete this. Right. So you will be required during exam to create a particular coordinate system at a particular point. So make sure when you are defining your coordinate system, a new coordinate system, you are using the correct direction as per the exam. So I'll go to the reference geometry coordinate system, and let's select this as an origin point, and this as my, oh sorry. So I simply clicked OK, and it created the coordinate system in the same way the global coordinate system is. But in the exam or during the exam, you may be required to change the direction. So how would we do that? So we define the vertex. Now let's say for X, I want this direction. For Y, I want this direction. And you simply need to select two directions only. And if you need to rotate the axis, you can just simply click on the arrow direction, go to that box, and you can just change it, right? So, and make sure when you create your coordinate system during the exam, you match the x's with respect to what is given in the exam. Okay. So now center of mass. Now we have created the coordinate system, and next step would be to measure the center of mass for that particular model. It could be a part, it could be an assembly with respect to that coordinate system. So, does anyone remember which which keyboard shortcut we used for the mass properties?
W.
Correct. We used W. So let's push W, and when we press W, we got the mass property window. And by default, the SolidWorks will report coordinate values related to the default system, which is this origin point or this direction. But since we have created uh, a new coordinate system, you will be required to use that. So make sure, because a lot of people miss this particular step out, that they do not select the correct coordinate system uh, to get this as the right answer. So let's see what differences it make. So you can see the center of mass is being changed when we moved from default to our new coordinate system. So make sure that you are not missing this point and you are selecting the correct coordinate system as requested by the exam. With mate. So this will be covered for the segment 3, where you will be given assemblies and you would be required to place them into a certain order with specific mates. So uh, you can choose any order of the mates. So if you have to assign like mate three mates. So you can choose any order of the mates, but make sure that you are using the right mate tools to define uh, your parts. So now I want to put this field onto this Excel, but I also want to ensure that it is in center with respect to rest of the assembly. So what I have seen people doing is like they will measure this dimension first, then they will either measure this. So both are 40. So we'll say, okay, so let's simply add, or let's do one trick over here. You can select an edge, and so with the Alt key, when you select an edge and drag it onto a circular part or circular entity, so it assigns two mate at the same time. One is the coincident mate, and second is the concentric mate. So these are the two mates which have been ended, right? So what they will do is like they will uh, use a coincident mate or maybe a distance mate to a certain phase. Now let's, so that is not the correct method or the correct design intent, because if in the future this overall geometry changes or to a different length, your wheel will be assigned to one particular side. So we have like two different options to tackle over here. One is called width mate and second is called symmetry. So depending on uh, your model requirements and depending on your model structure and the shape, you can use one of these tools. So let's look at both of them. So first, I will simply assign the concentric mate. So I'm again using the alt method. So, and I'll say, okay, now the wheel is concentric with this Excel, but it is free to move. Now, let's select these two tabs, press Control, and the moment you select four faces, SolidWorks will understand that you want to apply a width mate. So select the width mate and click OK. And now, if we change the size of this part, this wheel will remain centered into this particular assembly. And because we have assigned it to remain it in the center. Now, there is one more method of doing it. It again depends on how your model is. Because our model is symmetrical, we can use this method. So let's use the front plane. Make sure to select the plane or the face which you want to keep it as symmetrical. So I've selected the front plane. I'm pressing the control key, this face and this face, and SolidWorks will understand that you want to do a symmetrical mate. So we will get the same response or the same behavior as we got with the width mate. So you have to choose uh, which of these mate, either the width mate or the symmetrical mate, defines the best design intent based on your model shape and the geometrical needs. Gear mate. So this is again one of the advanced mate where you will be given a set of model and you will be required to do a mate either in 1:1 ratio or maybe in like a different ratio, and then move your component to certain degree to find the rotation angle. So right now this is free to move while this is fixed. So make sure, unless you apply the mate during the exam, you do not rotate, move the components. Otherwise, you will not get the correct answer. So I will select these two holes, and because now SolveX is not able to understand, like if you want to do a, a advanced mate, and based on your selection, it is just giving you different option. So let's go to mate command, right? Go to the advanced, sorry, the mechanical mates, and select the gear. Now, since these two shafts or these two holes are same, SolidWorks is assigning them 1:1 ratio. Let's do 1:, or let's keep it same, or you can do the two ratio, and you can define the direction based on the exam question, like whether it wants to rotate in clockwise or anti-clockwise. Now, let's check the mates for this one. So this is, they would require you to rotate it by 45 degree or maybe certain degree. So let's edit this mate, change it to angle dimension, and let's move it by 15 degree. And then you will be required to check the angle of the second component with respect to a certain plane. So I used again the M key to find what is the angle. Sometimes SolidWorks gives you a completely different angle. So make sure what you do is you can either draw a sketch in the assembly. Let's do a quick sketch over here. Oh, I'll convert this one. Now I'll give this angle value. So you can find the angle like this, or you, if you are not comfortable doing a sketch in the assembly, you can just draw a quick drawing, and there you can find out the desired angle, just to make sure that whatever value you are selecting is correct. Because sometimes what happens when we are checking this exam and we have selected a wrong face, SolidWorks may give you a completely different angle, which is like uh, 90 minus the desired angle or 180 minus the desired angle. So make sure either you are using a sketch method to or the drawing method to verify your answer before attempting to that question. Path mate. So again, you, while you are building the models, you will be given a particular file which have the path, and you will be required to do a path mate and make some changes to that path mate to get the desired answer. So let's do a path mate. So I'll go to the mate command. I'll go to the advanced mate, and I'll select the path mate. So first I need to define a vertex, basically a point. So it can be a vertex, it could be a sketch point, it could be even origin to define as my starting point or my vertex point. So I'm selecting the origin of this particular component, and then for the path, I'm selecting this spline as my path. Now, when you do path, you can also do a selection manager. If you have like, if you do not have a spline, but you have a closed or connected entities, you can select them using the selection manager, and it will bring up the options to select one by one, or select in the chain, or select all of them. And when you do a path, you get different options, so which define your path constraints. So first is free. Free means the component is free to move along the path. Then you have distance along the path, so you can define like how much distance, so you want to move it 10 mm, 12 mm, 15 mm, or you also get the percentage along the path. So it is same as distance along the path, but instead of the distance value, you are defining that I want it to move by 15% or by 25%. So so depending on the question, you can use one of the options. So let's select percentage along path, and I'll define it as 15 as a start. Now, then we'll press W to get our com value, which is this one. And then in the next question, or maybe you will be asked to change this path from say 15% to 47.5, and again check the mass properties and fill in the answer. So you have to make sure that two things: you need to make sure that you have defined the path mate correctly, and when you are doing the coordinate system, sorry, checking the center of mass, you have selected the correct coordinate system. Interference detection. This is similar to collision detection. Collision detection is when we move components in an assembly, and if they are interfering, there is a tool in SolidWorks that says stop at the collision or collision detection, and the moment two parts will collide with each other, which means they will touch with each other, SolidWorks will prompt you and it will stop moving the parts. And then there is an interference detection, which is a slightly advanced version of collision detection. So when your parts are moving within a certain range, and if there is an interference, you can use this tool to find out where is the interference in the model and how much is that interference. And then based on that uh, output, you can find out, or you can decide what is the next step to remove that interference. So let's look at this model, right? So right now we see that the part is fixed, and we do not see any interference, and there could be some mates which you may be required to do, say, change from, let's say, from 15 to 10, and then do a interference check. So for interference check, I have assigned a shortcut of Q. Interference detection is also available for multi-body parts, which means if you have a part which has multi-bodies, you can also do the interference check in that part model also. For older version, it was only accessible for the assemblies, but for some of the latest version, it is now made accessible to parts as well. So you select, and you can do two types of basically two types of interference detection when you are into the model. You can check the interference for the complete model. So let's do that first, and it will list you all the interference it finds in that particular model. And you may be required to find interference in particular two components. So if that is the case, so instead of running the interference detection for the complete assembly or the complete model, just select the desired components and then do the calculate. So you can it will give you the value of how much interference is there and which particular component are interfering, and then you can enter that value into the your answer question. Now, second, we were talking about the collision detection, though you may not be asked to do any collision detection during the exam, but let's look at it. So for that, we have option called move component, and in move component we have collision detection, and then we can say, okay, we can select all of the components, or we can use particular component, right? And we can tell the SolidWorks to do stop at collision. Did you hear the sound it made when we we were doing the part movements, because there were certain parts which collided. And if you look at, maybe these two parts collided, or they were about to collide, or maybe this particular component collided. So let's try it again. It will highlight those particular component. So we can see that shaft, it is it is it is colliding, right? And there are some other collisions as well. Maybe this one is colliding inside somewhere. So using these tools, and it is not only for like linear components. If there are rotary components, you can use the same tool, which is called rotate component, and it gives you the same option where you can rotate your assemblies, or if you have rotary assemblies, you can rotate them by using a free drag, or you can also do like about an entity, or by providing some value that rotate this or move this particular component or assembly in x-axis by certain amount. So you can do that as well, and you will get the same answers. Override mass properties. So you will be requested during the exam to change the mass properties. That could be the mass of a particular file or an assembly or its center of mass, and then give the answer or provide the answer that by making this change, what is the overall change in the main assembly. So I'm using the same assembly again, and let's change or overwrite. But before that, let's see the mass property for this assembly using our coordinate system. So it is 5.5, 1.25, and let's say it's 0.8. Okay, now let's go into this part. I'll again use the W key. I'll click on this override mass property. We can override the mass. We can all, as requested by the question. So let's make it 2.5, and let's override this as 2 to 0.5. Now, why we have to do mass override sometimes? Sometimes we get uh, components which are standard components, and we may not have all the details which gives us the correct value of this the mass or its center of mass. So for those particular components, overriding mass helps us in defining the correct weight and center of mass for that particular component. Now let's close it, save it and close it. Now let's see. So you can see our center of mass has changed from 5.8, I think it was 5.8 and 1.25, and then 0.8 to 6.3, 0.99, and 1.946. So make sure you know like which particular component you need to do the mass changes for, and uh, based on that, your answer will change. And like I have been stating earlier, also make sure to use the correct coordinate system. The replace component. So using the replace component, what we can do is we can swipe an existing component with a new one to if there are any change, or if, for example, one particular component that is now obsolete, and now a new part has been made in place of that, and for all the production job we need to use that new part. So instead of creating the complete component or the assembly from scratch, we simply swap the parts. It's simply like if you have a car and the tire is worn out, so you take out that worn out uh, um, tire from the car and replace it with a new one. So instead of like building the complete car from scratch, you are simply replacing the worn out component. So, so okay. So basically, from this, we will be replacing from a smaller crank assembly to a bigger crank assembly, right? Let me open up that assembly as well. So this is my original assembly, and I want to replace it with this particular assembly. Now, for that, what we can need to do is we need to right click on the component, and we do replace component. Sometimes this replace component does not show up on the right click. So if that is the case, make sure to go to the arrow at the bottom of the right click menu, go down until you see customize menu, and then you make sure that your replace component option is selected. Otherwise, it will not show up on the right click, or you have to keep scrolling down to get to this option. So simply right click, replace component. Now, when you have this into the replace component manager, SolidWorks will show up all the open components in the backend, and you can select which particular component you want to swap it with. And then it also now gives you the option. Earlier it used to replace all the instances. So example, if you have like 10 instances and you just want to replace two of them, you can select all the replaces over here, and then you can either select all the instances, or you can select the particular instances. And then for the mates also, you can, it will automatically match the name, or you can manually select them, and then it will reattach the mates. So if we click OK, and it has automatically selected all the mates, and then we click OK, and again we will be required to do a center of mass after this component has been changed. So obviously there will be change in the center of mass, or even in the assembly complete mass, because these particulars are longer than what it was there earlier. Okay, so last fun quiz before we almost get to the end of the presentation.
Fail.
Oh yeah, that's correct. Thank you. Okay, so like I was said, you will get two type of questions, mainly two type of questions for all segment. One will be where you have to enter an answer, which you can simply copy and paste. If it is from mass properties, or if it is from center of mass. So depending on how you want to answer that question. And second type will be multi type questions, where you have four or maybe like more options given, and you have to select the right answer. And then again, in the multiple choice questions, there might be questions where you have to select more than one answer. So it is through the exam that you will see these types of exam. And some of the multiple choice question uh, will will be in accordance with the last questions. Like it will be a follow up from the previous question, where you have to modify certain dimensions from the previous question to get to the answer. So make sure your answers are within 0.5 plus minus 0.5% of one of the answer. If it is not matching with one of the answer, then there is a possibility that your answer is not correct. So make sure you verify your model again and correct if needed, and also make sure to check the previous answer which was you have been following along. Now before the exam, make sure to use these settings. This will help you to save a lot of time during the exam, and also give you peace of mind. Create two templates. Though most of the questions will be in metric system, but I still advise that create two different templates, one with the inches system or imperial, and second with the millimeter or metric system. So make two templates for the model and two templates for the assembly. You can assign them any name which makes it easier for you to recognize. Usually what I do is, like, if I have to give the exam, I put the exam name uh, followed by the type, if it is a part, drawing, or assembly, followed by the unit system. So that's how I assign my templates specifically for when I'm giving the exams. And on my daily basis, like if I'm working on projects, so what I do is, like, I assign them by type followed by the metrics, the unit system. So for example, part underscore mm, or part underscore in, or similarly assembly underscore mm, or assembly underscore in. Set the decimal places for your templates, 3 for inches and 2 for metric. You can also assign global variables in advance, like you can create A, B, C, D different variables for the exam and assign any value to them. So this is completely option, but definitely it will save you some time during the exam. Uh, Usually, we do not assign colors to different feature, though it's always helpful to have different colors to the feature so that we can simply recognize them. But specifically for the fillet feature, I would advise to assign a different fillet, different color, so that when you are applying fillets to your models, you can correlate it with the pictures given in the exam and make sure that you have applied the fillets on the desired location and you have also put them the correct values. Always customize your keyboard settings, like setting up the S key. You can use mouse gestures, keyboard shortcuts, so that you, like we were talking about that for measure we are used M tool, M key for mass property. We use W key for collision detection. We used Q key. Similarly, you can assign other tools or other shortcuts as well, which will help you save time during the exam. Uh, this is specifically for the new people like who recently started using SolidWorks. That what they can do is just keep some of the command tabs available, and rest you can remove them temporarily from your command manager, right? So before you do that, make sure you export your settings using the settings wizard. You can find it under the tool setting wizard. Let me show you. So tools, save, restore settings. Here you can click that and you can save your settings before you make any changes. And after the exam, you can restore your old settings the way you want. So this will help you remove any unwanted tabs from the command manager from the screen and help you save your time in navigating to the desired features or to the desired commands. Now, those were the things when we want to do the template setting before the exam. Now, there are certain advices I would advise to do before you do the exam. Oops, sorry, they are in different order. Well, make sure before you give the exam to restart your system. So uh, do not start uh, the exam in front of like sorry, in between any project. Make sure to restart your system. Make sure to clean your desktop and the recycle bin. So what when you do a virtual tester, if you have given any exam earlier, right? So usually the virtual tester will create a folder on the desktop, and it tends to save most of the file or the files you download during the exam on your desktop. So make sure you keep your desktop clear. This will help you find your files easily, clear all the temporary files, run SolidWorks, and make sure everything has been put in place, which means the command manager, the shortcut keys, do a quick model to check the shortcuts and everything is working. Download the latest version of the virtual tester from the 3D Experience virtual tester website. Now, once you're ready for the exam, log into the tester application, and to make sure it is still working correctly. Also, make sure to close all the application in the back end. Like I've seen, like people they will open up some other files. Though it's an open book exam, which means you can open up any PDF, any help file, or even Chrome, YouTube's, just to verify a button, just to check a certain feature or a command. But I usually advise to close all the application which may not be required during the exam. So this will help you save some memory, and if possible, use a dual monitor setup. Dual monitors means same machine but with two monitors. And if you want to use two different monitors two different systems side by side, make sure you have the possibility of transferring the file from one machine to another, because you will be required to download certain files from uh, during the exam for certain questions. And finally, make sure to use the latest version of SolidWorks. But in case you do not have the SolidWorks, make sure to use at least 2015 version or anything above it, because some of the files in the exam they are made in 2015 version. Now, that was what we need to do before the exam. Now, what we need to do during the exam, make sure you keep your model simple. That way, if you have to make any changes, you can easily change it. So do not over complex, like sometimes just to speed up things, like people do a lot of features or a lot of sketches into one feature or in one particular thing, which make it over complex when you have to edit something. Unless uh, you have the design intent clear, I would advise to keep the model simple. Make sure you fully define your sketches. Many users have reported their answer was not matching even for the sample exam. And the reason behind that, they had not defined a particular sketch which gave them uh, the answer which was off by a certain amount from the correct answer. Avoid sketch fillets or pattern wherever possible. So I'm not saying like do not use it, but if you can avoid sketch patterns or sketch fillets, try to use feature fillets or feature pattern wherever possible. Check all the questions. So I would suggest you, like if you are doing a complete segment in one go, to go through all the complete segment first before you start answering the questions. So from question one to the last question, uh, it will be a run through of what changes you need to make from one to the last, and that will give you an idea of what design intent I need to follow to make sure I am following the right steps and getting the correct answers. Save each part separately with a question number. So what I do is, like when I gave the exam, I did S1, which is segment one, then question one. Or you can create three different subfolder: segment one, segment two, segment three, and then in segment one you can say question one, question two, question three. So even if it is the same file which you are going to use in the next question, just save it as with a question number, so that when you have to revalidate your answers or recheck something, you can easily find that particular question or each model respect to that particular question. Uh, this is one thing. So it's not only related to the exam, but also related to what we do in our production life. That make sure to save your files often, because we know SolveWorks sometimes loves to crash for no reasons. To make sure you save your files during the exam as well. Check your models and answer while you go through the exam. Like I was talking about that gear question, that sometimes it gives you a very angle in a different way, to make sure that you use a different method to verify that whatever answer you have found is all correct. uh, you can also copy paste an answer into the text box, but make sure there are no spaces before and after the answers, because that will invalidate your answer. Finally, when you have done the exam, you can click on the summary button. Make sure you do not press the end exam button, but simply summary button to review or glance at the complete exam to find out which, if there are any questions which you have not answered. Now, the final quiz.
Firefighter.
Correct, firefighter. Okay, so these were the things, or these were the topics we have talked about, like which can help you understand how the exam is structured. But of course, you will need some material where you can find files or some exercise files or some other things. So I have uh, worked out a list which have both like and paid options, where which will help you in learning SolidWorks, enhancing your skills and SolidWorks, and also there is material for preparing for the SolidWorks exam. So you can go to this particular link, and it will have resources to learn SolidWorks as well as exam. I will share this link into the chat once we are done with the presentation. Or okay, now we will open up for the questions we have. So
Sir, before that, I will be sharing you that participation certificate link. Please fill out that form. That's all.
So I'll be happy to answer questions. You can type into the chat if you want, or you can also have your mic on. So we have open mic as well, or we can. So I have shared the link in the chat.
We have got it, sir.
Yes, hello. Hey, good evening. Actually, I'm Edwin.